It all started in 1976 as a two-player arcade video game called Blockade. It inspired other arcade games like Surround and Dominos. Mattel released Snafu in 1982. The same year, Snake Byte was published for Atari computers and Nibbler, a single-player arcade game. The famous Tron arcade and its light cycles are a player versus AI variant on the Snake game concept. In 1991, there was Nibbles for MS-DOS and Rattler Race released, where the snakes eat apples. In 1997, it was chosen as a preset game for Nokia cell phones, followed by Snake 2 in the year 2000. Since then, there were countless small flash games with many different takes on the gameplay and graphics. Let's make our own version and add our own little contribution to the video game history. In the resources section below, you can download a seamless repeating background image. It will repeat seamlessly, both vertically and horizontally, and it will cover the entire game area regardless of its size. In my project folder, I create a subfolder, I put the image there, and I point background URL property to it. Constants.js will hold all important constant values our project needs. This is a grid-based game, and we need to define the size of a single cell in that grid. I want cells of, let's say, 55 times 55 pixels. I console log cell size to see if the file is connected and working. All good. Grid will be made out of 10 columns and 12 rows for now. Another constant I call game. It will be an object. Width of the game will be columns times cell size. Height of the game is rows times cell size. We are including constants first. Main.js comes after, so I have access to those values from there. I could have done modules and export-import statement, but I want to keep this simple. For export-import to work, you need to create a local server. The project I'm building here can be opened simply by clicking index.html file in any browser. It's very easy to refactor this into ESX modules if you want to at the end of the class. I want this to be as beginner-friendly as possible. We are using images, so I will wait for the entire page and all assets to load before we run any JavaScript code that depends on it. Inside, I do simple HTML canvas setup. I point JavaScript towards the element, then I take that reference and I initiate 2D rendering context on it, allowing us to draw and animate anything we want. Canvas width will be game from here .width. Canvas height will be game.height. Canvas size is updating, so I know all the files are connected and working. I remove the border. CTX variable, context, now gives us access to all built-in canvas properties and drawing methods. If I console log it and inspect it, we can see default fill style is black, but I can override it to blue if I want. We also have, for example, this fill rectangle method here. It expects x, y, width and height, and it will draw a rectangle for us, like this. I can change these values to move it around or to resize it. We know that everything works. Canvas is set up and we can draw on it. I create a new JavaScript file called snake.js. I include it here after constants.js, but before main.js. Inside, I create a constant variable I call snake. It will be one of the main game entities. In this project, I will spell my constants with all capital letters, and my entities will start with a capital like this. Snake object will have a position property, which will also be an object with two properties for x and y coordinates. We will also need velocity. So we have a snake with x and y position and x and y velocity. I give it a draw method. It will expect context as an argument. Inside, I call built-in fill rectangle method. Position x and position y are not coordinates on canvas. They just represent the position of the cell in the grid, the number of that cell in the grid. So if I want to draw the head of the snake horizontally, it will be at this.position.x times cell size. Vertically, it will be this.position.y times cell size. Width and height will be cell size, like this. In main.js, because we included it after snake.js, we can use the snake object here. Yes, I can take it and I call its draw method from line 4. It expects context as an argument, so I pass it ctx from line 3. From there, we will call built-in fill rectangle method to draw the head of the snake. Position X and Y represent the position of the snake in the grid, so by giving it different values here, the snake moves around the grid. We will move it around here inside the update method. For every animation frame, we increase horizontal position by horizontal speed and vertical position by vertical speed. If I call update, just here, it will run only once on the first page load. I move the snake to position 0, 0 in the grid. We want to update and draw the snake over and over to create animation. Custom function I call animate. Inside, we draw and update the snake. Built-in set interval method calls a function at specified intervals. Function I want to call is animate, and I want to call it every 500 milliseconds, twice a second. We will animate at 2 FPS. The snake moves across the game board. We can see old paint. I want to see only the current animation frame, so I will clear canvas between every draw and update call. Values we give to velocity x and velocity y will determine the direction of movement. We are moving one cell down per animation frame now. We are drawing only the snake head. Let's give it a body made out of multiple segments. Let's say at first it will be 3 body segments. We will hold those segments here. This will be an array, and each segment will be represented by a simple object with x and y properties, the position of that particular body segment in the game grid, like this. But we will fill those segments in using built-in array unshift method. The unshift method adds the specified elements to the beginning of an array. For every animation frame, the snake moves to a new position in the grid, and we push new segment and we give it x and y position of the snake head. As the head moves around, it is leaving body segments behind. I want to draw each body segment, so we will iterate over the array, and for each body segment, we will draw a rectangle. The segments have x and y properties, so here I use segment x and segment y. That worked. The length of the snake is 3, so if the length of the segments array is more than 3, we use built-in array pop method. Pop method removes the last element from an array. We add a new element to the beginning using unshift, and we remove the last element using pop. This creates a crawling snake animation. If I change velocity like this, snake will move to the right. The length of the snake will match the value we give to length property here. I can change these values to distribute the grid and cells in a different way. I can increase length here. We know that we can make the snake move in a different direction by changing values we pass to velocity x and velocity y. Let's add controls. Move up method, move down, move left, and move right. When we move up, horizontal speed will be 0, and vertical velocity will be -1 cell per animation frame. Negative direction on the vertical y-axis means up. Move down will be 0 and +1. Move left will be vertical speed 0 and horizontal speed -1. Negative direction on the horizontal x-axis means left. Move right will be +1 and 0, like this. I create a key down event listener. Callback function generates an event object. I give it a variable name and I console log it. When I click on canvas and I press something on my keyboard, we see the event object in console. It has a key property with the name of the key that was pressed here. I console log event.key. Now I press keys I want to use as controls for my game, and I check how they are spelled. We will use directional arrow keys. Okay, good. If the key that was pressed is arrow up, spelled like this, we call move up method we just defined. Arrow down is move down. Arrow left is move left, and arrow right is move right. I might have to move this event listener inside the load event later. Let's see. I can now control my snake. Perfect. For each method, auto generates an index as it iterates over the array. I can access it by giving it a variable name here. For example, I. Maybe I want the head to be a different color. Head is index 0, gold fill style. The rest of the body will be magenta. In constants.js, I give GameObject a GameOver property. Initially, I set it to false. I check for collision with walls. If position of the head is less than 0, if the snake moves past the left edge of the game, or if position of the head is more than columns -1, the right boundary, I do -1 because segments are rectangles and they are drawn from the top left corner. Top boundary, position Y is less than 0. Bottom boundary, position Y is more than rows -1. So if the snake moves outside of the game area in any direction, if it collides with a wall, we set game over to true. Inside animation loop, if game over is true, I call built-in canvas fill text method. I pass it the text I want to draw and X position of the anchor point of the text and Y position of the anchor point for the text. I want it in the middle. Text is small and magenta. Text align center, black fill style, font 40 pixels impact. We placed the anchor point in the middle of the screen, so text align defines the position of the text in relation to that anchor point horizontally. 60 pixels impact. Fill text method can accept fourth optional argument defining the maximum width of the text. If the text is wider than this value, it will be squeezed to make sure it's fully visible. Let's say I want maximum 95% of the game area. So if the game area is only 7 columns wide, we can still read game over. It's just a bit squeezed. Cool. Maybe I also want the game to freeze when game over happens. I give GameObject a new property I call loop. I give it some initial value. That value really doesn't matter. I set game.loop to this set interval. This will allow us to call built-in clear interval method when needed to stop the animation. Like this. The game freezes when game over happens. I create a new file I call food.js. I include it here after constants before snake. It's one of my entities, so I will give it a capital letter. It will be an object. Horizontal X position in the grid will be an integer between 0 and columns. Vertical Y position will be a random integer between 0 and rows. Food will be randomly somewhere in the grid. Draw method will draw a rectangle representing the food. I pass it X, Y, width and height. I call that draw method here. I pass it context. We see the food now. Maybe a different color? How about red? Blue? Inside update method on Snake object, we handle the eaten logic. Because we have a grid-based game, it's very easy to check for collisions here. We simply check if the snake head and the food sit in the same column horizontally and at the same time in the same row vertically, if they sit in the same cell in the grid. If both are true, we know head and food collide, so we call food.reset. I need to define that method here. It will just randomize X and Y position of the food again by placing it somewhere else in the game grid. It disappeared too early. It's a good practice to group the draw calls like this. Now if I play and eat, it looks better. Initially, the snake will be only 3 body segments long. When we eat food, we increase length by 1, and we increase score by 1 as well. I need to define score. Initially, I set it to 0. Every time we eat, snake will get 1 extra body segment. That works. I can draw the score from here, for example. Again, fill text method, text we want to draw, and X and Y position of the anchor point. text align left. After we resize canvas, which resets anything to default, I can set canvas font to 20 pixels impact. Things that don't change can be defined just once here. It's better for performance. Black fill style. Text baseline defines the relationship between the text and anchor point on the vertical y-axis. I want the text to go down from the anchor point, so I set text baseline to top. Bigger font, and I add some hard-coded text here, plus the dynamic score variable. I can also go to Google Fonts, for example, and I can use a custom font, maybe this retro game font. I click Get Font, get embed code here. I copy this code block and I paste it up here before my style tag. It also gives me the font family property here. I use it here. I copy this and I use it here instead of impact. I also use the font for game over message, 40 pixels here. 18 pixels here because this font is larger than impact. I move the game over message vertically a bit off center. I can also move the snake to start from the middle vertically. Rows divided by 2 and I round it down because we need integers. We want the snake to always snap to the invisible game grid. I remove the space here. When the snake collides with its own tail, I can trigger a game over, or maybe it will be more fun if we just make it eat its own tail and lose some score points. It will discourage the player from going through its own body, but it will not end the game completely. If you want, you can call game over here as well instead. We just covered how to do it. For each body segment, I will check if index is more than 0, which means it's the body and not the head. And at the same time, I check if position of the segment collides with the head of the snake horizontally as well as vertically. It means that the snake head hit the body. We will remove any body segments after that colliding body segment. +1 here maybe. Let's see what that will do. And we will punish the player by removing 5 score points. I could also make the number of points lost here equal to the number of lost segments if I want. I also make sure that the length property matches the new reduced number of body segments. I increased length to 8 body segments and I will try to eat my own body. We lose segments and we lose score. Maybe 15 to make it easier to see. Now it's clear that the snake lost many segments. That works. I can also move back through my own head and I can turn on the spot, which is something we want to prevent. Snake can only turn up if its current velocity y is 0. Snake can only turn up and down if it's currently not moving up or down. Only if it's moving left or right, because if it's already moving up, there is no need for this code to run. And if it's moving down, we don't want it to be able to turn up and move through its own body. It has to go around. I hope it makes sense. We only allow snake to move left or right if it's currently moving vertically, but not horizontally. Now the snake has to go around if it wants to turn back. It can't just walk through its own head backwards. I add one more line of text to the game over message. 18 pixels font size. It will say click here to restart. I move it a bit down vertically to sit under it. In Constants, I create a helper function I call reset game. When we reset, we set game over to false. We call reset method on snake and on food objects. Food already has a reset method. On snake, I define reset method here. It will set score to 0, length to 2. It will delete all body segments. It will set position to the starting values. Like this. And velocity to the starting values as well. Like this. Okay, so now we have this reset game function. I delete the console log. I add event listener for click event to canvas. When we click, we call reset game. Game over clears the interval, so reset method will set interval again. But only if game over is true, like this. I play. I get game over, I click and it restarts the game. Initial length will be 2. I will actually call reset game on the first page load as well to set all the default values. Okay, good. I want to use detailed sprite sheets, so let's increase the cell size to 55 times 55 pixels. 10 columns and 12 rows for now, so that I can fit it nicely next to my code and you can see everything side by side. You can download all art assets in the resources section below. I create a div with an ID of assets. I put my images inside. I put Magic Berry PNG into my project folders inside images subfolder. I give it an ID. I hide assets div and everything it contains by giving it display none. I give food object image property. I point it to Magic Berry image using its ID. Built-in draw image method takes at least 3 arguments: the image we want to draw and x and y coordinates where to draw it. The image is large because we haven't settled on the final cell size yet, so I will give it width and height to scale it down. I comment out these 2 lines and now we have food represented by the Magic Berry image. Nice. To animate the snake, we will have a sprite sheet with individual body parts and we will have to come up with some logic that will crop out individual frames and place them along the snake body in a way that makes visual sense. It might seem like a challenge, but if we take it step by step, it's actually quite easy. Let me explain that logic. I include my sprite sheet here. I give snake object image property and I point it towards the Snakezilla sprite sheet. Each body segment will be represented by a frame from this sprite sheet. Again, I call built-in draw image method. Image to draw and x and y position will just draw the entire massive sprite sheet with all its frames for each body segment. We already know that we can pass it width and height to squeeze the image into a specified area. Now we have the entire sprite sheet squeezed into each body segment. The width of a single frame in the sprite sheet I'm giving you is 200 pixels. I'm using large images. We can optimize them and make them smaller in the end when we decide on the final cell size. Sprite height is also 200 pixels. Draw image method takes image we want to draw and destination X, destination Y, destination width and destination height to define where we want to draw the image on a destination canvas. Finally, the longest version of draw image method gives us the most control. Source X, source Y, source width and source height define the area we want to crop out from the sprite sheet, and then we place that cropped out piece on destination canvas. If you understand this, you can do absolutely anything with sprite sheets and animated images. Let me show you. This is a very powerful 2D animation technique. I set X, Y, width and height of the crop area, and then we are placing that piece on canvas and fitting it into the width and height we set here. If you change the values here and watch what happens, it should make more sense. Try to play with different values and see what happens if it's still a bit unclear. So if I crop out an area from coordinates 0, 0 to sprite width, sprite height, we are getting exactly the top left frame. I can move the cropping area around by multiplying by the sprite width and sprite height. 2 times sprite width will move us here. 2 times sprite height will move us here. 2, 1 is this frame. Giving these multipliers different values allows us to navigate to any frame in the sprite sheet and to crop it out. Each body segment, as we cycle over them using for each here, will hold its own frame X and frame Y values. These will represent the cropping positions because each body segment will need a different body part from the sprite sheet. Okay, so each segment needs X and Y position in the grid and frame X, frame Y cropping area multiplier. So when I create the segments, I give them frame X and frame Y here. Again, the values we store here define the cropping area 0, 0, 0, 1. I create a helper method called setSpriteFrame. This method will run for each body segment for each animation frame. It will run some checks and it will decide which frame in the sprite sheet should be drawn for this particular body segment. We will need index of that body segment, its position in segments array, as we cycle over that array from 0 from the head to the last one, which is the tail. This method will be called from inside for each method as we cycle over the body segments, passing it index of each segment as we go along. So the body segment at this index, the current body segment we are trying to decide the sprite frame for, will be called segment here, to keep it simple. We know a few things for sure. We know that if index is 0, it's the first segment in the array, it's the head. We also know that if index is the last position in the array, length -1, we know that's the tail. Else, we know it's the body. In the else statement, as a fallback, I will crop out frame x6, frame y0, which is this berry. We know that as long as we see some body segments displayed as the berry, we need to sort them out. So as we cycle over this .segments array, for each segment we call setSpriteFrame method and we pass it the index of this segment we are currently looking at. We have 4 head frames, up, down, left, and right. We know that the first segment is the head, but we also need to know which direction it should be facing. We can easily determine that by checking the relative position between this body segment and the next body segment, the segment that comes right after the head, index +1. I have to say or 0 because if the snake is only one segment long, this code would give us an error because there would be no index +1 yet. If this segment we are trying to determine sprite frame for is above the next segment, less on the vertical y-axis means up, we want to crop out frame at position 1, 2. Else, if the head is below the next segment, we need a frame of head facing down, 0, 4. If the head is to the left from the next following body segment, we are facing left, frame 0, 0. And finally, if this segment, the head, is to the right from the next segment, we are facing right, frame 2, 1. We determined directions of the head based on the relative position between this segment, the head, and the next following body segment. For tail, we need the position of the previous segment, index -1. Or 0 if the snake is too short. So for tail, if previous segment is above the tail, above this segment, which we know is a tail, we need frame of the tail facing up, 1, 4. Else, if previous segment is below this segment, we need tail facing down. Small typo here, this should say more than. Okay, so now we have a tail when we go up or down. If previous segment is to the left of this segment, we need tail facing left, frame 2, 0. And finally, if the previous segment is to the right of the tail of this segment, we are moving right. I need frame 0, 1. We have the correct head and tail when we move in all 4 directions. This was easy. The body is represented by berries, and this will help us to see what is left to be done. We know if the segment is not head and it's not tail, it's the body. To correctly assign sprite frames to body segments, we need to consider positions of both next and previous segments in relation to this segment. We need separate left and right, and separate up and down because of the shading, to make sure the segments connect if the snake moves and curves in different directions. If the snake body was just one color, we could use only half of the following rules. If the next segment is to the left and previous segment is to the right, we are moving horizontally and right, so frame 1, 1. In the reset method, I set the initial length to 4. Okay, good. Else if the next segment is to the right and previous segment is to the left, we are moving horizontally to the left, frame 1, 0. Next, we will do vertical up. If the next segment is below and the previous segment is above, frame will be 1, 3. Finally, if next segment is above and previous segment is below, more than operator here. We move vertically down, frame 0, 3. We can move in all directions, and we only see the magic berry frame for the corner pieces now. Because of the shading, I have to make clockwise and counterclockwise wheels separately here as well. I start with counterclockwise wheel. Notice that I continue the same else-if statement. If the previous segment is to the left, and next segment is below, we are moving up and left, frame 4, 0. Else, if previous segment is below and next segment is to the right, we are moving left and down, frame 3, 0. Else, if previous segment is to the right and next segment is above, we are moving down and right, frame 3, 1. And finally, we move right and up if previous segment is above and next segment is to the left. Frame will be 4, 1. Now we get all the correct corner pieces if we keep turning counterclockwise. Left, down, right, up. If I start turning clockwise, we still see the berry frame, so we will finish that here. We continue in the same else-if block. Else if next segment is to the left and previous segment is below, we are moving right and down, frame 3, 2. Else if next frame is above and previous segment is to the left, we are moving down left, frame 3, 3. If next segment is to the right and previous segment is above, we are moving left and up, frame 2, 3. And last one, if next segment is below and previous segment is to the right, we are moving up and right, frame 2, 2. Great work, we have a snake that can move in any direction, no matter how long the snake is or how many times it turns. The sprites will organize themselves in any way that makes visual sense. In Snake 2 on Nokia phones, the snake opens mouth when it's close to the food. We have some alternative frames in our project. We have mouth closed, semi-open, and fully open with and without tongue. We can do all kinds of animations by swapping between these frames. When the head is facing up, we create 2 sub-blocks. If food is near, we do something. Else, we display the regular frame of the head facing up. While the snake is moving up, if the food is just 1 cell above the head and food is on the same column horizontally, we want to display head facing up with the tongue out, frame 7, 1. Same for the head facing down. Else is the normal head facing down. If the food is 1 cell below the head and in the same column, we display head facing down with mouth open, frame 7, 3. Left direction, standard head facing left. If food is 1 cell to the left from the head and on the same row, we display frame 2, 4. If the food is 1 cell to the right and on the same row, we display frame 4, 4. I remove the console log. I comment out the rectangles behind the snake. When we start the game, the first frame doesn't make much sense. It is because at first we don't have the previous and the next segments, and we can't correctly determine which sprite frame we need to crop out until the snake has at least 2 body segments. So when we start or restart the game, reset method runs, and inside we will create a for loop. It will run 4 times, length is 4, and it will just immediately create the snake body with all 4 body segments before we even start drawing anything. I used the same code we used before. We move, we place segment, and we repeat that until we created all the necessary segments. All this will happen immediately when we start or restart, so we will see the snake fully formed with the correct sprite frames assigned in the beginning and with the correct length. Let's make it move only for the second cycle to make it start 1 cell to the left, like this. I want a very small snake, only 2 segments at first. The only problem here is that if I mash arrow keys very quickly, we have a slow frame rate, and it is actually possible to change directions more than once per animation frame, and the snake can bypass the directional checks and still occasionally move through its own body. If that happens, we don't have a sprite frame for that, and we will see the berry image in place of that body segment. One way to prevent this would be to allow the snake to change direction only once per animation frame. Ready to move property will initially be set to true. We can only turn up, down, left and right if ready to move is true, like this. After we turn, inside we immediately set ready to turn to false, which will prevent any of the other turns to happen. We can only turn once per animation frame. Then, when update runs, we set ready to move back to true, unlocking the movement again. So once we turn in is locked until the next animation frame. We can only change direction once per animation frame. I can mash arrow keys as fast as I want. The snake is no longer able to move through its own body. Click the like if you found some value and let me know in the comments if you finished the class. We can take this to a whole new level. If you want to see how to make this into a 4-player battle arena with animated edible and non-edible foods, with sounds, particles, AI-controlled opponents, 2-player co-op and much more, check out this class. Art assets are cross-compatible between these two projects. Have fun!